So this morning, we are fortunate to have Pak Riswandi to present research that he did with a group of colleagues. You can see the names of the colleagues in his slide right now. And as I mentioned earlier, Pak Saiful Mahdi is also joining us from Banda Aceh. Pak Riswandi is affiliated with the Universitas Syah Kuala in Aceh, and he is also a PhD candidate at the Cohorts School for Public Policy at the Australian National University. So as I mentioned, Pak Riswandi, about 40 minutes for presentation, and then the rest of the time we can go into discussion and Q&A. Silakan, Pak.
Okay, terima kasih Bu Lydia. Good morning, everyone. First, I would like to thank everyone who make
recording in progress
significant contribution to this research, especially for staff in Pusat Penelitian Sosial dan Budaya Universitas Syah Kuala. They are very helpful when we conducting our survey. And then the second for the faculty members at the Faculty of Economics, Universitas Syah Kuala, and also for Indonesian project. So let me begin with this motivation of the study. Actually, this study has been conducted in Banda Aceh to look at the impact of the 2004 tsunami on child development. It has been long argued that investment in education is a very key strategy, a very important strategy for higher productivity and sustainable development. However, exposure to natural shocks, particularly during their childhood, can impair child development. And also, in many developing countries, support among children affected by natural shocks has not been a top priority. So this study tried to identify the long-term effect of the tsunami it can be used as a relevant policy and implement early mitigation measures. So this topic is very relevant for Indonesia as one of the world's most vulnerable regions to natural shocks. As we can see, during 2000 and 2019, Indonesia recorded the world's second highest death toll, about 187 dead due to various natural shocks like physical, hydrological, meteorological, and climatology disasters. Back in 2004, the 2004 tsunami killed around 220,000 people in around 14 affected countries, of which 1/3 were children. In Indonesian province of Aceh, the province is the hardest area hit by the tsunami. So the death toll is reached around 3.2% of the total population, around 38,000 missing, and about 12% of the total population internally displaced, and the economic loss estimated around 95% of the Aceh's domestic growth. As we can see here in the figure on the left, this is the satellite image of Banda Aceh before and after the tsunami. On the left figure, we can see here the area is totally damaged. So we can see how bad is the damage level in that area. There are many studies actually has been conducted to measure the impact of natural events such as famine, flood, and extreme weather on child development. But impact on tsunami on child development is very limited. For example, Yokomichi, Isozima, and Kikuyaya, they investigated the impact of the 2011 Japan tsunami on body mass index of preschoolers. So they found a higher prevalence of overweight among preschoolers in affected regions, but they do not find any evidence of underweight, which is one of the common effect or issues, particularly in developing countries. In the context of Indonesia, a few studies has been conducted to investigate the impact of 2004 tsunami on human capital. For example, case in 2014, they investigated the impact of parental death on the well-being of affected children. However, parental death might be endogenous, as we can see here. Parental death may be correlated to their pre-tsunami health conditions. So we are afraid that they cannot infer the causality. The second study conducted by Frankenberg in 2014, they investigated the impact of tsunami on the health of children, but selection might be a problem due to high mortality. So it could be the case that healthy children or healthy individual who survived during the tsunami, and they are selected as a sample in this study. So again, they may not establish causality. So we try to fill the gaps in the literature to provide the new causality evidence on the impact of natural hazard on child development. There are three objectives of the study. First, we to identify the long-term effect of the 2004 tsunami on educational outcomes in adulthood. The second, to investigate the heterogeneity effects by gender and by age group. And then the last objective is to explore the possibility channel through which the tsunami may affect educational and health outcomes in later life and the potential consequences of the impact. And also there are two contributions for this study. So this study is the first to investigate the impact of natural shocks and child development using spatial regression discontinuity design. And then the second contribution, this study is the first to study long-term impact after 15 years of the event. Because we're using spatial regression discontinuity design, this slide will briefly review what is the regression discontinuity design. Basically, regression discontinuity design is a way of estimating treatment effects in a non-experimental setting, where the treatment assignment is determined by whether running variable exceed a cut point of or threshold. And under this design, individual just below the cutoff are a good comparison to those just above the cutoff. So the treatment assignment in this design is argued to be as good as a random. In the case of spatial RD, we will use geographic border as a cutoff, and then geographic distance as a running variable. In our identification strategy, first we're looking for an area which is similar in terms of socioeconomic status, but half of the area was mildly affected by the tsunami, and the other half was heavily affected by tsunami. And then we use a spatial RD to estimate the causal effect by comparing outcomes variable of respondent aged 0 to 12 years at the time of the tsunami in heavily and mildly affected area. As we can see here in the left figure, Banda Aceh before tsunami, there is a adjacent area separated by river here, we argue that they are similar in socioeconomic status. And during tsunami, as we can see here on the right figure, the river reduced the strength of the tsunami wave. As a result, area on the left of the river badly affected by tsunami, but area on the right of the river mildly affected by tsunami. So we conducted self-assessment of the damage level through this satellite image. In addition to satellite image, we also asked in the survey to household with a question: was your house totally damaged in the tsunami event? As we can see here in the graph, almost 47% of total houses in a heavily affected area were totally damaged, compared to only 6% in mildly affected area. So there's a contrast level of damage in this adjacent location. So here is our setup of the spatial RD design. As I mentioned before, the very important variable in this design is the running variable, which is distance to the river. So this figure illustrates how we measure the spatial proximity under spatial RD. First, we measure the perpendicular distance from household K, here HK, to the closest points of the river, RK, and we measure the nearest distance, DK. This is one-dimensional running variable in our design. And then alternatively, we also use two-dimensional running variable. We measure the difference in X coordinates, here is AK, and then the difference in Y coordinates, BK. So in this design, the river is chosen as the cutoff or as a threshold, and then we'll assign the treatment. So those living here on the left of the river, AT, assigned as the treated area, and then those residing in on the right of the river, here AC, assigned as a control group. So this is our setup of the spatial RD. We use a linear polynomial in distance to the river as our main model. So YIK is the educational and health outcomes for individual I in household K. TK is the treatment variable, which is equal to 1 for household K living in the treated area, and 0 for those who living in a control area. DK, this is the running variable, distance of household K centered at the cut point. And then RIK is a vector of characteristic of individual I in household K, including status, sex, age, birth order, and mother's education. And then HK is a vector of characteristic of household K, such as elevation, distance to coastline, house facility index, and a number of dummy variable of whether household own gold or jewelry and own land in rural or in urban area. In addition to the main model, we also use alternative forms of spatial RD. First, we use a quadratic polynomial as in equation 2, and then linear polynomial with treatment interaction as in equation 3. And then we also use two-dimensional running variable, which is X and Y coordinate differences as in equation 4. All right, so this our study mainly use survey data from our survey conducted in Banda Aceh City. As you can see here on the left map, the red dot represents the household in the treated area, and then there is a river, and then the green dots represent the household living in control area. So in this graph, actually to emphasize that we have such an ideal setting for spatial RD in our survey area. If we can see here, this is our survey area, Punggay Blangchut village as a heavily affected area, and then Sukarame village and Stui village, which are in an adjacent area. If we move further to the north, on the left side of the river, those areas mostly used for high-rank official housing, school complex, and just a view of the area for community housing. So we afraid we don't have enough observation for control groups. And also if we move further to the north, both area of both sides of the river, as we can see here, they were totally damaged, so we cannot apply the spatial RD application because we cannot see any difference in damage level in that area. For sampling frame, we use list of household for heavily affected village. This list developed, I think, 3 weeks after the tsunami. This is the example of the list. There is in the second column there is name of the household member, and then age, and then I think status or relation to household head, and then the last column is remarks mentioning whether a particular household member died at the event, missing or still alive. So based on this list, we pick target household who have children or child between the age of 0 to 12 at the time of the tsunami, and then we select randomly the target household from the list. For mildly affected villages, we use 2010 population census, and then we select randomly household who have children between the age of 0 to 12 at the time of the tsunami event and have been living in the survey villages since before the tsunami. As I mentioned, we conducted household survey in Banda Aceh. Prior to the household implementation, we conduct 3-day enumerator trainings, and then to make sure that all enumerators understand the questionnaires and able to use mobile phone, because in the survey we use mobile phone installed using a survey solution applications by the World Bank. So this table summarizes the household sample listing, sample collected, and sample for analysis. Out of 820 households, we finally interview 521 households. During data cleaning, we dropped some observations. because they are moved out Banda Aceh city, or they don't have a target respondents. Finally, for sample for analysis, we have 439 households, 228 in control group, and 211 in a treated group. And also we have 696 target respondents, 358 household in control group, and 338 in treated group.
So target respondents are the children?
Yes, the respondent, the target respondent are children, but we also interview the household head for the household characteristics. This is the summary statistics in panel A, the geographic and household characteristics. Panel B, household characteristic. Panel C, respondent age 0 to 12 years at the time of tsunami, or 15 to 27 years old at the time of survey. And also panel D for educational outcomes, and then panel E for health outcomes. In general, household characteristics and respondent characteristics are relatively similar, both in mainly affected villages and heavily affected villages. Before we estimate the impact, this is a very, I think, very important and crucial steps when we apply spatial RD. We have to test the validity of the approach for two key assumptions. The first assumption is running variable manipulation. It means we want to test that the running variable is not being manipulated. So we this figure actually we test statistically the null hypothesis of no discontinuity of the running variable at the cutoff, and then we plot the figures here. As we can see here, at the cutoff, which is at the river, there is no a big jump, or there is no continuity of this graph. So we can apply the spatial RD. This is a very fundamental assumptions to be tested and to be successfully test, so we can use the spatial RD application. This test, we can translate it, these findings in the context of our survey. So before tsunami, household in the treated area cannot self-select their residential location to mildly affected area to minimize or mitigate the tsunami impact. And also the second assumptions of this approach, we test the covariate balance. As we can see here in table 4, most of covariate or baseline covariate are statistically insignificant, which suggests a respondent in heavily and mildly affected area have a similar characteristics. But some of, just few of the covariate is indeed significant. For instance, elevation, is it true? It is true that the household close to the household in a heavily affected area lower about 12 centimeters compared to household living in a mildly affected area. And also distant to coastline, it is true. So on average, household living in affected area closer 500 meters to the coastline. But we use this unbalanced covariate in our model. So this is the validity test. This table summarizes the treatment effect on educational outcomes. We have two educational outcomes: years of schooling and school leavers continue to higher education. We estimate the using the main model using three different buffer or bandwidths. So in column 1, we only take a household living around 169 meters from the river, both sides. So this H bar is the average bandwidth. We compute this bandwidth using Kalanico, Cantagno, and Titonic optimal bandwidth. And then the second column, we estimate the main model using 200 bandwidths. And then the last column, column 3, we use 780 meters both sides of the river, which cover all the observations. So as we can see here, children in heavily affected area tend to have a 0.5 to 1.3 fewer years of schooling. And also they are less likely to continue to higher education, around 17.1 percentage point to 28.9 percentage points. We also provide the plots for the educational outcome, as we can see here. Panel A for years of schooling, and panel B for school leaver continue to higher education. So these two graphs support our test from table 5. There is no upward discontinuity at there is an upward discontinuity at the cutoff, indicating children in heavily affected area tend to have lower educational outcome. So we can see here these lines slower than this line. It means those living in this area have fewer years of schooling. This table summarizes the physical health outcomes. As we can see, there is no significant impacts of the tsunami on health outcomes except for height here. So children in heavily affected area are on average shorter, around 1.2 standard deviation than those in mildly affected area. And we provide also the plots here on the right. For robustness test, we use 4, I think, different tests. First, we use OLS. So this test without running variable or without distance to the river. And then the second robustness test, we use alternative forms of spatial RD, quadratic polynomial, linear polynomial with treatment interaction, and then linear polynomial using two-dimensional running variables. And then the next robustness test, we use non-parametric regression discontinuity. In this case, the bandwidth chosen by the data behavior. So data-driven bandwidth. So H here is different with H bar here in parametric regression discontinuity. So here H is automatically produced by if we use a stata, there is a comment to produce this optimal bandwidth, which based on the data driven. And then for the last robustness test, we use a fake cutoff. So we hypothetically shift the river or to the left or to the right from the original river as long as 100 meters and 200 meters. So as we can see here, our main results are robust, relatively robust to other alternative models or forms of spatial RD. But maybe we just focus on the last robustness test. It could be that there is a positive impact. There is a significant impact of the tsunami. But if we move further from the river, like 200 meters, the impact vanishes or the impact disappears. So as we expect that there is no impact if we use a fake cutoff. This table summarizes the treatment effect by gender for female, column 1 to column 3, and male, column 4 to column 6, with using a different bandwidth. And we still find under female column here, female children in heavily affected area tend to have 0.8 to 1.8 less years of schooling, and about 31.2 to 39 percentage point less likely to pursue higher education. For height outcomes here, both female and male children in heavily affected area shorter, around 1.2 for male and 2.1 standard deviation for female. And also in the last row here, male children in heavily affected area are more likely to be underweight, around 28.9 percentage point. We also conducted subgroup analysis by age group. So we divided the sample into two groups. First, for younger cohort, those who age 0 to 5 years at the time of tsunami, and then the older cohort, age 6 to 12 years at the time of tsunami. As we can see here in the last column, column 5 to 6, older cohort is heavily affected area tend to have a 0.9 fewer years of schooling, and less likely to pursue to higher education, around 20.2% to 26.6 percentage points. And they also have a higher prevalence of asthma, around 12 percentage point. For younger cohort, they experience younger cohort in a heavily affected area are on average shorter, about 1.2 standard deviation. Yes, so we also identify the possible channel. We use standardized Raven score as a proxy of cognitive abilities by gender and by age. But we only find significant results under older cohort. It means children at the age of 6 to 12 years old in heavily affected areas seems to have lower cognitive abilities compared to children in the same age in mildly affected area. For potential consequences in labor market outcomes, we estimate these two labor market outcomes, income level and employment status. So if they are employed, 1, otherwise 0. So we can see here for income outcomes, children in heavily affected area are likely have lower income in later life. But we do not find any significant impact on employment status. This is the last slide, the conclusion. So the 2004 tsunami causes fewer years of schooling, less likely to continue to higher education, and shorter height among children in highly affected upon their adulthood. There is evidence that cognitive distortion could be a possible channel that improves educational outcomes in adulthood. And then the lower income upon their adulthood can be a potential consequences. So the last conclusion is related to the public policy, I think. So this result provide a much stronger argument to further develop policies that could significantly help children affected by natural shocks, including provision of nutrition for children affected by the disaster. I think that's all the presentation for today, Mbak Lydia.
Thank you, Pak Riswandi.
Yeah.
Very clear presentation. I have a few questions, but first, I invite everyone attending this morning, both on YouTube and also on Zoom. Now I see on Zoom more than 60 people. To write your question in the Q&A box, or you can also click the raise hand icon. You can find the raise hand icon at the bottom of your screen, and we will unmute you to ask your question directly. So you can use either or both of those options if you would like. So I see there is one raised hand from Pak Abdul Nasir. I'm going to open your microphone, Pak, but you have to allow from your end. Harus disetujui. Silakan. Yeah, okay. Yeah, we can hear you, Pak. Go ahead.
Thank you. Great presentation, Mas Riswandi. I have two questions. Maybe one is a suggestion. Could you get back to a balance test, please?
Balance test, okay. Maybe.
In your balance test, the result is some covariates are significant, right?
Right.
Because they are significant, my question is, can we really conclude that both group in the treatment and the control group have similar characteristic? Because you mentioned about that. Mm-hmm. The second is, I think it's a suggestion in your robustness test, especially in the fake test.
Yeah.
So the expectation is actually insignificant, right? The results should be insignificant, but we see there are some positive impact, and when you move further, then the significant disappear.
Yeah.
My suggestion is, could you provide another test with the further distance to see whether the result is still insignificant, to see the result is really stable. Thank you.
Thank you, Pak. Great to see many friends, colleagues from Canberra joining us. Feel free, and also I see Pak Nazamuddin. Feel free to ask questions or put in the comment box. So that's one. There was a question from Arianto Patundru, but katanya sudah lihat. He already saw it in the presentation. If you would like to ask a question in Bahasa Indonesia, that's also fine. Silakan. kita terbuka dan ini kita santai saja. Jadi untuk pertanyaan itu dulu karena cukup banyak ya. Silakan Pak Riswandi.
Ya, terima kasih. Thank you, Mas Nasir. Yes, there are some, I think 1, 2, 3, 4. There are 4 covariate were not unbalanced, and we afraid that the effect may be driven by these 4 unbalanced covariate. So what I did, we include this, I think, unbalanced covariate in the regressions. So we control for the difference in covariate behavior before the tsunami. That's the best thing that we can do for the covariate balance. We include it in the estimation to control for this unbalanced behavior. And the second one for robustness test, yes, it is doable to make a further distance as long as we have enough observations in both sides. Because if we move further to the left, let's say, so it means if you move or shift hypothetically the river from the original river, let's say 500 meters. So we don't have, I'm afraid that we don't have enough observation on the control groups, because when we move to the left, all those who were in the treated group now become in the control groups. So it is doable, but as long as we have enough observations. I think that's my comment, Mas Nasir, and thank you very much.
Okay, thank you. Again, I invite, if you would like to ask questions, to write it in the Q&A box. And also on Zoom, if you would like to give comments, please write it in the comment box and we will transfer it to the Zoom room. So I was very interested to see the 2 ways that you use to identify the distance to the river. The one is using the difference in X and Y coordinates. So I'm assuming that this is because it's spatial analysis, you want to see the topography. That's why you use the X and Y coordinates, difference in X and Y coordinates. So if I'm wrong, please correct me. So another question that I had, you had mentioned about children, is it 6 to 9 years old with cognitive, lower cognitive function, cognitive abilities, characteristics. So if they are 6 to 9 years old, that means they were not born when there was a tsunami. So can we, what can we take away from this finding, Mas Riswandi? So that's from me. So before you answer that, maybe I see 2 people raising their hands. There is Rifki Tenribali Esha Nazir. Bapak atau Ibu Rifki, please go ahead and unmute yourself.
Testing, can you hear me?
Yes. Yes, we can hear you. Silakan, Pak. Yes, yeah.
Yes, thank you. I am a graduate student, university, very technical to understand.
We can hear you, but putus-putus, Pak. It's is it possible you speak slower so that we can hear you better?
Okay. I will into the submitted in civil conflict and tsunami. This was, but the education, physical health, and cognitive abilities of children in Aceh and Banda Aceh were already like impacted or underperforming due to civil. To want to add, and as you know, health and cognition elsewhere in Indonesia impacted shocks and disaster is what I would like to add. But besides that, it was very yes.
So Pak Rifki, we can hear tapi putus-putus ya. So if I can repeat the first question, is that because you mentioned that there was civil unrest, so that was the outcome that impacted after the tsunami. Is that that is observed? Is that the question? Because we can hear you, but it's a bit putus-putus, so we cannot hear the continuity of the question. Pak Riswandi, is it my connection or what about you? From your end, can you?
Yeah, I also experienced the same thing. I can't hear very clear. I cannot hear clearly. So,
okay.
But I got a point. It's not wrong if it is not wrong. So the civil war in Aceh might be as a driven for the effect of the educational outcomes in this study. Is it true?
Okay.
Okay.
Yeah, Pak Rifki, if you would like to ask your question again, we can try again, or otherwise, if you would please write it in the Q&A box.
I think it's frozen, Pak.
Okay. Okay, Pak Rifki, we will move to the next one, but feel free to write it in the Q&A box, and then we can respond to your question. So I see two more, but I think maybe we address my question first, and then Pak Rifki, and then we move to the next one.
Yeah, thank you. I think Mbak Lydia, the first question is about this. I think can you see the slide on how?
Not yet.
Not yet. Okay.
You have to share again, I think.
Okay, share again. Yes. So this is the main idea. This is just illustration of our idea to measure the proximity using spatial RD. So there are two alternatives. First, we can use one-dimensional running variable, which is distance, the closest distance or perpendicular distance, or we compute the difference. So HK here, HK is the household location. This particular house has latitude and longitude. And then also this river, this closest point of the river from the house also has latitude and longitude. What we did actually, we subtract the x coordinates and also y coordinates. So this might be similar. I think this is from the Pythagoras, I think. So this to measure this distance squared equal to this distance squared plus distance squared. So the idea is relatively the same. That's why we want to use this two-dimensional running variable as robustness test, whether our result is robust when we use one-dimensional running variable, and then we retest or re-estimate using two-dimensional running variable as the running variable in the model. And then for the second question, 6 to 9 cohort, if we can move down here, I think this is the result. Yeah. Oh no, this one. Oh no, this one. This one. Yeah, okay, this is Bodilia. So the question is, Where's the cognitive? Yeah. So the cognitive, so only children age 6 to 12 who experience lower cognitive abilities due to the tsunami. That's our findings. So the question is, not sure, what actually the question, Mbak Lydia?
So if they are 6 years old, then in 2009, they are 6 years old, then they were not born yet during the tsunami.
No, oh, okay. So this age group means the older cohort means they were 6 to 12 years old when the tsunami happened.
Oh,
so,
okay, when the tsunami happened.
So
okay,
now we ask the relevant questions in the questionnaire to children aged 15 to 20, if I'm not mistaken. Yeah, 15 to 20 years old at the time of the survey.
Okay.
Yeah.
All right. Okay.
And then for Rifki, I think the survey area is relatively safe from this conflict. So that's why they have a similar characteristics in terms of the influence of civil war. So if both sides are safe, and then the outcomes in later life difference solely because the impact of the tsunami, not because of the civil war. If we take, let's say, one survey area in the conflict and then the other area in the safe without conflict, then conflict civil war may induce or might affect the difference in the outcomes. But in our survey, we argue they are safe and they are in the capital city, which is relatively safe from the civil war. I think that's my comment for the question from Pak
So Pak Rifki already wrote his question. So the first part is answered. The second part is, do you think we see similar effects of fewer years of schooling and being shorter or underweight in other disaster-affected regions in Indonesia? So that's the second part of his question. Before you answer that, Pak, let's take two more questions from Pak Nasamuddin. Pak Nasamuddin, we have unmute you. Welcome, Pak. Please go ahead to ask. And the next one will be Arianto Patunru.
Thank you, Mbak Lydia. Well, this is a very excellent presentation, Riswandi. One thing I am wondering about is the connection between the outcomes on health and the outcomes on education. I'm wondering whether you are also investigating the connection or the relationship between those two variables. I see the outcomes like underweight and also the loss of years of schooling. But is there a connection between the two? Thank you.
Thank you, Pak. Next, Acho, if you would like to ask your question.
Thank you, Lydia. Congratulations, Riswandi. I'm a big fan of this work. Can you put back your slide on, especially slide number 10?
Yeah. Oh, okay. I should share screen. Yes, Pak.
Number 10, the map. Yes, thank you. Apologize if I had asked this question in some other seminars that you provided here at ANU, but I'm still not very convinced that the design of your study actually support or can answer the research question completely that you raised before, because you basically are trying to see the impact of the tsunami on two different communities you call heavily affected and mildly affected. But if we look at the picture and also when we cross-check with the data, basically these two communities are not very different in terms of, for example, their distance to the coastline. And also when you draw this a river, right? The distance to the river also is not very, well, they're different, but not so much. So I was thinking, why not observing those who are not affected? So for example, on your right-hand side of this slide, I'm not sure if you have data of those who live very close to the right, lower right side, close to that box, the white, one of those white areas, right?
Mm-hmm.
Instead of actually comparing two very adjacent communities, because this way, basically the story is like whether or not those who live left to the river is different from those who live right to the river. That's the question that, I think can be motivated by this graph, not the impact of tsunami on some community vis-a-vis the other communities. Because in this context, both of them are actually affected. We just call them, one is mildly affected, another is heavily affected. Because I think this can affect the precision or the power of the policy implication you would like to propose to whoever policymakers, because they will, at the end they say, well, these are the same communities or almost the same communities, right? So that's my comment. Maybe maybe I'm wrong. So I'm looking forward to your response to that.
Yeah.
Okay.
Thank you.
Thank you.
I think let's address the current questions first, Mas Rizwandi, before we move on. So from Pak Rifki, from Pak Nasamuddin, and from Acho.
Yeah. Thank you, Pak Nazam. So I think we test the channel through which this health outcomes and educational outcomes may be affected by the tsunami through cognitive abilities. So there are many literature saying that once children affected by adverse experiences, natural shocks or other natural event, the first impact is through their cognitive abilities. Once once got impact from cognitive, then may impact their ability to go to school. And also, I think nutrition provision during after the tsunami may also induce the lower performance in health outcomes. I think what I am thinking now is to find one relevant variable to measure the deficiency of nutrition after the tsunami that might explain the long-term outcomes in health performance. I think that's my comment. Thank you, Pak Nazam. And for Pak Acho, yes, things as it's sensible saying that we compare those who are totally not affected as a control group to those totally affected as a heavily as a treated group. we actually I'm not sure whether we also conducted a survey in this area, because this is in one village. This one, I think your question related to this one. We have sample for those living in this area, relatively unaffected.
Actually, I wonder if you have data further down. So on the right side of your on the map, not the photo, the map on the right side. If you go to the right, all the way to the border, right on the one of the white areas. So, do you have those observations?
Yes, we did, Pak. We have, I think, around 50 households.
Okay.
We interview in this area.
That area. Yes.
This is, but unfortunately, we cannot apply this
RDD
sign. Because when we test the validity of the assumption, there is a jump at the cutoff, which is the river. We cannot use this application.
Okay.
Maybe using different approach or different methodology can be used to measure this impact.
Okay, thank you.
It's good, very good input, Acho. Thank you.
Thank you.
Yeah. Related to Acho, my comment is then about the river itself. Maybe if you are comparing these two areas, maybe it would be more convincing if you say something about the river to show that it's actually stopping the tsunami, and what it looks like, and so on. So that's my comment. So I think you have one more question from Pak Rifki, which is the comment on whether you think fewer years of schooling and shorter or underweight can happen in other disaster affected regions.
In Indonesia.
Yeah, in Indonesia.
Yeah, I need to further work on the literary review to find these findings and then compare to ours, so we can have a general conclusion about the natural events on educational and health outcomes. But that's a very nice comments. Thank you, Pak Rifki.
Okay, so let's go back to the questions, and I see Pak Abdul Nazir raising hand again with a follow-up question, I guess. Silakan, Pak.
Oh, no, Mbak Lydia.
Oh, okay. So it's masih diturun ya. Okay. Yeah. I will lower the hand then. Sorry.
Okay.
Kalau Pak Nasir nanti bisa
itu ya.
Dekat
But it's okay, because then we all learn from the questions, right?
Yes.
So there's orang jauh juga, Umbu Raya raising hand. Please go ahead. I see your question is on the Q&A box, but I think everybody will be happy to hear from you.
Thank you, Lydia. Hi, Rizwandi. Great presentation. Hello. Yeah. So I have a question, or probably like just asking for clarification or additional information on gender analysis in page 17 of your presentation.
Yeah.
So what we see there is that the tsunami has heterogeneity effect on female and male in educational attainment, but not necessarily in nutritional status or health status. What do you think is the story behind those results? Thank you.
Ya, halo, ini senior saya nih, Mas Umbu. Thank you, Bang Umbu. So we compare the female in heavily affected to those female in unaffected area. So we are not comparing female to male, but we are comparing female to female in different situation. So what we can conclude for these findings, again, there is what we call lower participations for female, particularly in heavily affected. I'm not sure whether this is very good reasons. Maybe they have to discontinue their schooling to help family members in their household, or they have to marry earlier, or that's why they don't continue their study. And yeah, I think that's the possible explanation why they have a lower educational outcomes. I think is that answer your question, Raya? Or you may have other thought about this finding, so we can put in our report.
Yeah. So maybe for this variable, it might be useful to compare both both areas before the tsunami, if there is some data to show whether they were before the tsunami, that between male and female, even before the tsunami, there is a disparity. I don't know if that's possible. Yeah.
We don't have at the individual level, unfortunately.
Yeah.
Not sure whether socialness or at the household level. We at the time we don't have any data unless the PODES potential village, but it's not at the individual level. And I'm not sure whether this village are the sample for this survey. So it's a good idea to compare before the tsunami between
between male and female. Maybe even I think just as a background for Banda Aceh, for example, in general, or Provinsi Aceh in general. Does that answer your question, Pak Umbu? And if there are follow-ups, feel free to raise hand again. So I see that there is Nimade Sukartini in the Q&A box, asking if you observe other social impacts of the disaster, for example, social capital or trust, individual risk, or individual time preference, risk and time preference. So that's from Nimade Sukartini. Before Pak Riswandi answer that, I would like to invite if you would like to give comments, or not always question, but also comment is okay. And if you are in YouTube, please write it in the comment box. We can transfer it to the YouTube Zoom. Silakan Pak Riswandi on this from Ibu Nimade Sukartini.
Thank you, Bu. Bu siapa tadi?
Nimade Sukartini.
Nimade, Bu Nimade. We collected this data, and we will work further on using this capital social, because we asked in the survey using I think EFLS questionnaire to capture the social capital and other related question on this term. So we can use this survey data to answer these questions. Thank you. Yeah.
Okay. So I don't see. Okay, I see Pak Rifki asking another question. Why do you think older cohorts of children on average lose more years of schooling and do not continue to higher education compared to the younger counterparts?
Maybe the economics reason. I think they have to help their parents for the economic purposes. They maybe go to labor, child labor, maybe, but we don't statistically investigated this possibility explanation. this possible explanation. But this might be the case that the older cohort experience lower education.
Okay, thank you. So I don't see any other questions. So feel free to ask if you still have something to ask. I see Arianto Patunru raising hand again. Silakan Aco, and also I have another follow-up question after. Silakan.
Sorry to ask another question again.
It's okay.
And
We have plenty of time.
And if I can go back to the previous discussion, sorry about that. But I understand now. I wasn't careful when looking at your slide. But on your slide, you actually said that the survey is an ideal setting for the spatial RD. I didn't know, but I have no idea about spatial RD. But I guess that for spatial RD, you have to have two adjacent localities. But the two adjacent localities are separated by something that can really separate them on some regards, right? So I'm thinking U.S.-Mexican border, for example, right? Mm-hmm. But in this case, you are claiming that this separation is based on the effect of the tsunamis, right? Not by something related to the river itself, and not, related to tsunami, for example. I don't know, whatever it is. But this is about tsunamis. Then the tsunamis can go through the river, and then it will overflow to both areas. And I checked your elevation; they're not very different, right? So I'm assuming that the effect of the tsunamis could actually destroy the houses in both areas more or less equally, right? So that's my question. And I think to motivate your paper strongly, you need to actually provide a story about how severe the impact of this on these two locations, and provide contrasting stories, contrasting views, like how many houses are broken, how many, number of deaths. Maybe it's on your paper, but I didn't see that in this presentation, to motivate that they are really actually in contrast one another. Thank you.
Yeah, I think that's related to my comment. I from my perspective, I would like to hear more actually about this river. That is it's a natural barrier, right? For the in this case in your study, it's the story is that it's a natural barrier for the impact of the waves, and therefore the area on the right-hand side is the right of the river is less impacted. So it would. I think there are also some policy advice that can be given in terms of environmental management and keeping, this natural capital in working condition and so on.
Should I respond, Mbak Lydia, to Pak Aco?
Actually, let's see. I see Pak Nazamuddin, and no open question in Q&A. But Pak Nazamuddin, silakan Pak Nazamuddin, so that you can address.
Yes, briefly related to the questions raised by Pak Aco. I think the way the river flows to the sea, you see the bands it looks like a binding, what do you call it? It's like a winding river, so that the effect to the left, I think could be very different from that to the right of the river. As shown in the figure on the right of the slide, shown by Riswandi. I think by assuming, I don't know whether Riswandi mentioned about that, but the characteristic of the river would slow down the wave. Because I know that the sea is to the north of this figure. I think so. The impact would be different.
Okay. Thanks, Pak Nazam. Nice to hear you, Pak Nazam.
Thank you.
Semoga sehat, Pak.
Yeah. Same for you.
Okay, silakan Pak Riswandi.
Yes, I think I agree with what Pak Nazam said about the river. So actually, we do self-assessment on the level of the damage caused by the tsunami. First, we use the satellite image. So if you can see the roof of the houses. On the left of the river here, the roof is almost gone. I mean, the roof of the houses almost we can't see that. But here we can still see the original house. The roof is there, still there, and etc. And also we also asked in the survey, maybe this will support more stronger. Will support stronger our identification strategy. And also we don't put this anecdotal evidence. When we did the survey, we actually asked the community here in the safer area, and we asked what happened when the tsunami coming. We thanks to the river, because the river slower the wave of the tsunami. That's why our house here still safe, although there is water coming into the house, but the house itself is still there.
Did you put this in the paper, Riswandi?
No, not the.
Yes, I think you need to put a stronger narrative contrasting the two damages, right? Because you cannot just ask the reader to look at the picture here, look at the photo. No, you can't do that. But if you have strong narrative, I think this can be very really strong paper.
Okay. Yeah. Thank you, Pak.
Okay. There is another follow-up question from Pak Rifki Tenribali in the Q&A box. So this is related to the findings about asthma. What may cause higher prevalence of asthma in the older cohorts, especially since symptoms of asthma can appear in children at almost any age?
Yes. Yes, thank you, Pak Rifki. So the possible explanation may be when the tsunami happened or tsunami occurred, mothers or parents will, carry on the babies, not those who age 5 to 12 years old. They already, they can run away from the wave, and that might be the cause of the asthma, because spontaneously they run, but those who age under 5 years old, their parents or their caregiver will help them at the event of the tsunami. I think, although this is difficult to prove, but that's one of the possible explanation why those older cohort might suffer more, or maybe some other. Pak Saiful, mungkin ada yang mau ditambahkan untuk mensupport ini?
Yeah, I see that several co-authors are here, Pak Saiful, Pak Budi, and earlier I think I saw Milda as well. If Milda is still here, feel free if you would like to comment or add anything to the presentation.
I didn't know they're here. Now I have to run.
Why? I know, because I'm the master of the Zoom room. Okay, silakan kalau ada. All right, so because we are nearing 11 and I don't see any other comments or questions, I think we can give a big round of applause and thanks to Pariswandi. I hope the comments have been useful for you.
Very useful.
Great paper. And I hope it is also inspiring for the other researchers here. If you are students, for example, I know that there are some students of Professor Arif Anshori who was assigned to attend so that you can see methods in causal inference. So welcome and hope that this is inspiring for you for your study. So with that, before I close, with a big thanks to Pariswandi and everyone, please keep safe in this pandemic. Hopefully we can get out of the pandemic soon. And before I close the Zoom room later, I will put up announcement of our event next week, which will be on Friday. So thank you, everyone. Thanks for coming and see you at the next FKP. Thank you, Pariswandi.
Thank
Good
you,
luck.
Bu Lydia.
Rest of the paper.
Thank you, Mbak Lydia.
Okay.
Thank you, everyone.
Thank you, Pak Saiful.
Top, Arif.
Thank you, Pak.